how do we find the inverse of a 3 by 3 matrix? So I want to first make it clear that if we do the determinant of A and we find out that it is not 0, this is a non-singular and that there will be an inverse. So inverse, we put a tick on it, alright? But if determinant of A is 0, that is a singular. In order to find an inverse of A, for example, we need to take 1 over the determinant of A multiplied by the adjugate of A. I'm going to teach you guys how to find each of them, so don't worry. Let's start off with the determinant. So I have a separate video on how to find the determinant of a 3 by 3 and a 2 by 2 matrix. So if you want to go and take a look at it, I'm going to do this one real quick though. So first, how I do it is I take the first two columns, so 2 1 1 0 4 1. Alright, and now I just take the diagonal from top left to the bottom right. I'll just show you. Alright, so 2 times 0 times 8 equals 0, and then I'll add 2 times 4 times 1 equals 8, and 3 times 1 times 1 equals 3. And then this together will minus the other diagonal. So that will be 4 times 0 times 3 equals 0. 1 times 2 times 2 equals 4. 4. 8 times 1 times 1 equals 8. So add them together, and then the determinant of A will now be 8 plus 3 equals 11 minus 0 plus 4 plus 8 equals 12. And then hence the determinant of A is -1. So what we have here, -1 is not 0, so it is a non-singular and that there will be an inverse. Take note that this determinant is important for later, so let's just put it on a side. It's gonna be pretty big, so okay. So we first take the determinant of, and then now we do the first row, first column. We cover that. We have 0 to 1 8, so 0 to 1 8. So we take the determinant of this, 0 to 1 8, and then we take the determinant of, okay, now we take the first row, second column, so 1 2 4 8, so 1 2 4 8, and then now the third one, let me see if I can clear this. Alright, now the third one would be determinant of, so third will be first row, third column, 1 0 4 1, 1 0 4 1, and then we just repeat it down here. So that'll be determinant of, okay, sorry if my handwriting is a little bad, I'm on a mouse. So second row, first column, so it'll be like this. So 1 3 1 8, 1 3 1 8, determinant of, now the second row, second column, that'll be 2 3 4 8, 2 3 4 8, and then we just keep repeating. So it may be a bit confusing, but just, it's like this arrow and then this arrow. Make a little X, start from the top left and make a little X. So 0 times 8 is 0 minus 2 times 1 equals -2. 1 times 8 equals 8 minus 2 times 4 equals 8, that's 0. 1 times 1 equals 1, and then 0 times 4 equals 0, so 1 minus 0 equals 1. And then 1 times 8 equals 8 minus 1 times 3 equals 3, that's at 5. 2 times 8 equals 16, 3 times 4 equals 12, so 16 minus 12 is 4. 2 times 1 equals 2. 2 times 1 equals 2, minus 4 times 1 equals 4, so 2 minus 4 is -2. 1 times 2 is 2, minus 3 times 0 equals 0, so that's 2. 2 times 2 is 4, minus 1 times 3 is 3, so 4 minus 3 is 1. 2 times 0 equals 0, minus 1 times 1 equals 1, so that's minus 1. Alright, now that we have the answers for this, right, so we have all the determinants, I want you to imagine a little box, and in this little box there is an X made of a bunch of pluses, alright, and in between there is just negatives. Okay, I want you to implement the signs into this thing that we have here. So I'll do it in red. So negative on the top, on the left, on the right, which flips the sign to a plus, and then over here. Now that we have this, 0, it just goes away, and then this becomes a plus. Okay, it's a minus, it's a minus. Alright, now that we have this, alright, we need to take the transpose of what we have here. So what a transpose is for me, how I understood this is, imagine a diagonal mirror. Okay, like imagine this red line is a mirror. Imagine this red line is a mirror that goes from top left to bottom right. Okay, now we're gonna flip whatever we see on each side. So this -5 will go here, and the 0 they'll basically change places. The 1 on the furthest top right will go to the bottom left, and then this will exchange with this. And what we have over here now, which is the transpose, like let's just like transpose this. This will be -2, and this is a -5, and then 2, because the 2 goes to the top right. This 0 comes here, this stays the same, this stays the same, and this 2 exchanges, so that will be 2, and then this will be 1. Right, now we have the transpose. Now we finally have the adjugate. Just to be clear, this is a cofactor. This is called cofactor, and this is the minors. But just to keep it simple, I'm not going to tell you what they are. I'm just going to tell you how to solve them. Okay, what we have over here on the right is the adjugate. So let me just clear everything. This is adjugate of A. Alright, now we're going to go back to the formula. Alright, A to the inverse is equal to 1 over determinant of A multiplied by the adjugate of A. So if we put in this formula, it will be 1 over -1, which will turn it into -1 times adjugate A, which is this, right? So let's just put it over here, -2, -5, 2, 0, 4, -1. Sorry, my 4s are a little bad. 1 here, 2, -1. And then to find the answer, we'll just have to multiply 1 across all of the matrices. So -1 basically just flips the sign. So let's just flip all the signs. So 2, 5, -2, 0, -4, 1, -1, -2, and +1. So it's 1. And now we have the inverse of A. Alright.